So I'm happy to talk to you about the topic of literary translation in the area of large language model. And so this is joint work. Unfortunately, now I still wanted to add the first author, Han Sang. She's my PhD student. Didn't work out in time to the technical problems. This is joint work with my PhD student, Han Sang, and also Wei Xiao, who's also here today, and also Li Macken from Ghent University. So now what I will be talking about is I give an introduction to what is machine translation, just very briefly, because I think most of you will be familiar with machine translation. Then I will talk about what is literary machine translation and what are the challenges of literary machine translation. How have large language models been used for literary translation? And then we're going to make a short Mentimeter. I'm not sure if I can access the results because they would be on my computer. And then at the end, the longest part of the presentation will be two recent papers about LLMs for literary translation, which have opposing results. And I'll present those to you on a high level. And the last thing that I'm going to present is our most recent work, which is an evaluation metric, automatic evaluation metric for evaluating the quality of literary translation. All right, what's machine translation? I guess most of you will be familiar with this. You have a source text in a certain language, then you have a machine translation system. It could be a black box system that's using different components, NLP components, AI components, statistical modeling, maybe a deep learning neural network. And then ideally is producing the correct translation in a target language that you desire, for example, English or Chinese. And noteworthy is here, so this translation could be on a sentence level as shown in this example, but it could also be on the paragraph level where you have multiple sentences, or document level, or on the level of a complete book. Brief history of machine translation started after the Second World War, unsurprisingly, when people were interested in, for example, translating between English and Russian. At the time, people had rule-based systems. So, for example, there could be a rule that tells you how to translate a certain word in a certain context. And then, roughly around the 1980s, people were starting with example-based machine translation. Basically, they had a corpus, let's say, of 100 examples of already translated texts. And then when at inference time, when a new translation comes in, they look in their database of 100 translations of maybe there's already something that is similar. And then they would use a similar translation for that. And that then is the basis, starting from the 1990s, for statistical machine translation, where people start to train statistical models on hundreds of thousands or millions of examples of translations, for example, German to Chinese. And they would train a statistical model on that, and then ideally that statistical model would generalize over the examples. And then from 2014, 2015 onwards, people were still using the same paradigm, but then switching to a different statistical model, to deep learning, like in all other areas. And this is the paradigm that's still dominating until today. Of course, today we often have large language models as the statistical models. Now, MT could be considered a solved problem nowadays. So it was once considered the holy grail of NLP. So people thought that if you would be able to solve machine translation, you would be, so that's the highest problem that could be solved. And if that would be solved, then everything else would also be able to be solved. But nowadays, there are some claims that it's nowadays a solved problem. So starting at the latest from the second half of the 2010s, we have those papers talking about human parity when it comes to machine translation, where human parity means that the automatic models are as good as human translators are. All right, so this is the setup. Now we have arguably literary machine translation as a specific subproblem of machine translation, and one could argue that this is the current research frontier because it's much more challenging than traditional machine translation, for example, news translation. And it's much harder for a variety of reasons. For example, one of the reasons being that literary could be considered non-standard, sophisticated language with complex syntax. Context length becomes important. So if you have a news document, maybe it's just you can still argue that you might be able to do this on a sentence level or on the level of a few sentences. But for literary translation, it seems much more adequate to treat this as a problem where you have, for example, a section of a book or the whole book to be translated, and then you have issues of discourse consistency, of named entities, which should be translated consistently across the whole book. And other aspects are cultural adaptation. So when you translate, you may want to adapt to the target culture to have the same effect on the audience of the target culture than you have in the source culture. And I'll show you an example of that in just 2 slides. And finally, literary translation are often characterized by creative changes in order to accommodate stylistic constraints or effects in the target language. So it's often a creative task, and I'll show you also examples of that in the next 2 slides. And there may be more issues why literary translation is particularly difficult. Okay, let's look at an example. Now, this is a special case of literature. It's a poem, Die Bürgschaft from Friedrich Schiller. Zu Dionys dem Tyrannen schlich Damon den Dolch im Gewande, ihn schlugen die Herrscher in Bande, etc., etc. Now, the question is how to translate this. So here's a human translation. And this human translation in English has a property that, one important property in the German original is that there is a rhyming pattern. So for example, you have here schlich and sprich, which is rhyming, Gewande and Bande, which is rhyming, wüterich and sprich is also rhyming, befreien and bereuen. Now this is a stylistic effect. And the human translator here has decided not to keep this keep this rhyming pattern. So this is, of course, a decision of the translator to do it in this way. Now, in this case, decided not to use that. But otherwise, the translation is rather close to the original, especially when we compare it to another human translation shown here. So now this translator has decided to actually keep the rhyming pattern. So you have sneak and speak is rhyming, dagger and feather is rhyming, speak and league is rhyming, and tyrant and repentant is also partially rhyming, just like in the German. You see here another translator has decided to keep the rhyming pattern, but otherwise is a little bit farther away from the original. So we can see some differences. So for example, the German original talks about the Dolch in Gewande. So it's a dagger in the cloak. And the first human translation has it here actually. So here's the dagger, and the dagger is in the cloak. But the second English translation has decided to remove the dagger from the translation for reasons to make it more enjoyable for the English reader. Maybe it's more fitting to omit this and therefore to have the rhyming pattern contained in the translation. So this is one change. This is an omission. There's also lexical choices which are different than the original German. For example, in the German, it's talking about the wüterich, so this is the angry man, but in the English it becomes the despot. Or the city, so the German original talks about the city, and the English translation talks about the state. So we see here the human translators, at least the second one, decides to actually take on this task a little bit creatively and make some changes along various dimensions. And I think this is a special challenge of literary translation. All right, when we look at cultural aspects, so here's now different examples from the TV episode The Simpsons. So we have a discussion between Mr. Burns and Smithers. And now in the English original, I highlighted some words for you. These are some named entities: Snoop, Doggy Dog, Bob Barker, David Brenner, Rory Calhoun. And in the German translation, they decided to change those named entities to very different named entities. So, for example, instead of Rory Calhoun, an American actor, they decided to put in Boris Becker, a German tennis player, which some people may still know. So this is an aspect of cultural adaptation. Why did they do this? Obviously, they did it because the original is supposed to be funny, and if it's supposed to be funny for German also, they cannot just use people which are totally unfamiliar to a German audience. So this is cultural adaptation, another challenge of literary machine translation. Now, when we talk about this, literary machine translation we should not only talk about technical solutions, we should also talk about ethical concerns, and there are quite a few ethical concerns. In the last 1.5 years, I have talked to quite a few literary translators, and they have a lot of reservations against artificial intelligence. They are facing job losses or wage reductions, and now is the first time, perhaps in their history, where they really feel the threat quite strongly, right? So before, the systems had the reputation of maybe not being able to handle this challenge. Now we have those large language models, maybe they are able to handle this challenge. And they also experience mixed emotions, usually negative emotions of anger and fear regarding AI usage. What they complain about is, for example, data piracy, that these models are trained on data which perhaps they have produced without being fairly compensated. And they also articulate environmental concerns, that these models use a lot of energy. And overall, I would say there's a very strong negative bias towards AI. So that is my experience when I talk to them. Some people even told me, so I know where the system is failing, but I will not tell you because we don't want the system to get better. And they also have concerns that if the translating companies are more and more relying on AI and believing that AI is a good solution, then perhaps that could deteriorate the quality of literature. So these ethical concerns are actually very important. All right, let me give you a brief history now also of literary machine translation, just the last few years. So before December 2022, before the release of ChatGPT, we had maybe some early approaches to that, rather in the context of corpus building, document level machine translation. So literature naturally associates with document level machine translation because literature is often a book, and a book is just longer, and then you need to translate on this longer unit. And there's influential work by the group of Moed Iyer. So they have released a corpus in mid-2022, I think. And they also discussed the document level MT for literary translation. Now, starting from 2023, we have direct comparison between large language models and humans. So again, a very influential work by the group of Moed Iyer in the United States. So they basically, they have the claim that large language models are especially good at this document level machine translation for literary translation, but they still claim that the models at the time still make critical errors. And then in mid-2024, we have this other paper here, which says, okay, we're already at the time of beyond human translation, and they use multi-agent collaboration to claim that they can induce a system that's better than humans. I'll discuss about this paper. And we have also a paper which was published just a few months back at NACL, where we asked the question, how good are large language models for literary translation really? And we look at human evaluation of LLM-based literary translation and also automatic evaluation. And I'll talk about both of these papers in depth in the second part of my talk. And then finally, I also talk about our most recent paper, which is about a automatic metric that we believe is much better than previous automatic metrics in judging the quality of LLM-based machine translation for literature. Okay, now there would be a Menti if the audience is interested in a bit of interactivity. If you can go to this Menti link. And what we have now, we have a text here. This is Jane Eyre from Charlotte Bronte. And I can read the English. It says, where the northern ocean in vast whirls boils round the naked melancholy isles of farthest Thule, and the Atlantic surge pours in among the stormy Hebrides. So this is the original. Now we have 4 German translations for those of you who speak German. You can go there, and now it could be that 0 of those translations are by a human, or 1 or 2 or 3 or 4, and you could make your choices what you think is translated by a human and what is translated by a large language model. And maybe give you like 2 minutes to read those poems, and if you're interested to make the Menti. No, I keep yours, I just look in. Okay, maybe we do the final minute, 1 more minute. If you want to cast a vote, please do it now. Okay, last 10 seconds. Okay, let's conclude. So people are saying that the second translation is most likely a human translation. Also, the first translation is most likely a human translation. And the last 2 have also received some votes, about roughly half of the votes of the first 2 choices, and this is actually correct, that the first 2 are human translations. I only see part of the picture, so I have to look here also. So first 2 are human translations, one from 1864, one from 2020, and one is Google Translate, and one is GPT 4.0. And yeah, it's actually nice that GPT 4.0 is ranked a bit higher than Google Translates. When we look at the translations, what we can observe is that the LLMs are much closer to the source text than the human translations. What they do, for example, you see here, there is this phrase of farthest Thule, and both machines have translated this quite literally. Das entfernteste Thule kocht oder brodelt, and even they have kept the syntactic structure in terms of a semicolon. And you see that the human translators are less strictly sticking to the original text. So the second translation by Ingrid Rein does not have this structure that the English source text has, for example. So we see here, that's also an important lesson. The large language models stick much closer to the source text than the human translations, which are more creative. All right. So now let me talk about this first paper, which claims that we're now at the level of beyond human translations. This paper is from mid-2024, and I think, and now it's going to be published in TACL, one of the most prestigious journals in the NLP community. And what they do is they have an LLM-based multi-agent system where every role of the translation process is replaced by a large language model. And then they claim that their trans-agent system is better than humans. So here is an outline of the system. So this is multi-agent system. We have a translator here. There's a proofreader that interacts with the translator, gives him or her some feedback. There's a junior editor is also providing some feedback, and all these agents have some roles in providing some information to the translator. So the main idea is use large language models to simulate the roles and collaborative practices of a human translation company. There are 6 roles: the CEO, the senior editor, the junior editor, the translator, the localization specialist, who is there for the cultural adaptation. So saying, okay, we're here now in a Chinese culture, you have to translate things a bit differently, and a proofreader. And so each one of those people has a profile, or each one of those agents has a profile with certain demographic, names, nationality, age, personalities and hobbies, skills, and the profession. And then they receive a prompt that tells them, now you are that person and you are a highly esteemed editor and your task is such and such. And what's happening then is the CEO selects a senior editor, and the senior and junior editor, they give translation guidelines. What they also do is they look at the source text and they look at words which they think are important words, and they also look up the translations of those important words, and they provide a summary of the whole book. So they also do book level translation, like they say ultra long text. So they provide a summary then to the translator, and they provide a glossary of important terms, and they also give an estimate of the intended target audience. Maybe this is a children's book, so you also should translate in the form of a children's book. So they look up this information and then give it to the people down here, the translator, the localizer, and the proofreader. And these 3 interact with each other in a form of doing an action, doing a translation, and making a critique of that translation, and then finally a joint judgment. So this is their process, and more details are in the paper if you want to look up. Now let's look at their results. They do 2 forms of evaluation. The first evaluation doesn't take into account the source text, it just takes into account the translation. So you just have a translation, and then they ask humans which translation is better, but they don't see the source text, right? They just read the translation, which is a bit odd, right? If you think about it, you just have, it could be a random text, right? Like 2 random texts, and then which random text is better. And then they also have a bilingual evaluation setup where the source text is included, but they say for our human translators, it would be much too costly to also read the source text because of the target texts are already super long. So they cannot also, in addition, read the source text. So for that bilingual evaluation, they use automatic metrics. They use like a LLM as a judge to evaluate the quality. Now, in both cases, what they do is, or what they find is, here's their trans agent system in green, their trans agent system winning. In both cases, they find that their trans agent system wins against GPT-4 and also wins against reference 1. Reference 1 is a human translator in the majority of cases, more than 50%, right? So from that, they conclude that their system is better than humans, also better than GPT-4. All right, so that's it. These are the results. Now we can ask ourselves, can we trust those results? And then our answer is perhaps no, right? And why? So we have several concerns about that. So first one is the human translations. So that this reference 1, we don't know much about these people. They don't talk about these people. Who are these people? Are they literary translators? Are they random people? How experienced are they? But they actually take the easy way out because they relate to a shared task which happened like a year earlier. And in the shared task, they were establishing this data set. But then you can go to the shared task paper and they just say these are professional translators. So, okay, we can imagine perhaps they are professional translators, but we don't know, are they very experienced people? Are they more junior people? We still don't know. Then the human evaluators in their setup, so they had human evaluators that were judging the quality. So they also don't provide much information. We just know they are from the United States. We don't even know if they're native speakers or not. We basically know nothing about them. What we do know is that they were very cheap. So they cost like 30 cents per annotation instant. So yeah, so it's maybe not very, very experienced people. The monolingual human preference, of course, doesn't make sense to judge the quality without the source text, right? Just seeing the translation. They make actually a good point in the paper. They say this is a realistic scenario because in practice, if I read a novel in German, I also don't care about the source text, which could be, right? Well, maybe I just care about the translation output. But still, it's a bit problematic to just judge source translations without the source text. And then this other evaluation, the bilingual LLM preference, this can be criticized by the known fact that LLMs have self-biases and they prefer their own output over human outputs. So maybe the second experiment that they have might also be flawed. So can we conclude that their results are false? We cannot conclude that, but we just believe that maybe it's not properly evaluated and would need proper justification. All right, and then this comes to our work. So we believe the evaluation of literary text is a challenging task. And we discussed this in this paper, how good are LLMs for literary translation really? And we have several findings. A few of the findings that we have that I want to outline to you is it matters a lot who is evaluating the text, and it also matters how the text is being evaluated. And finally, our overall conclusion is that, at least in our experiments, under our conditions, LLMs are not yet at human parity. So I show you a bit about the data set that we construct. It's called lit-eval corpus. We have verified human translations, multiple human translations, and it's a paragraph level parallel corpus, so meaning that there's like source documents, source documents which have multiple sentences, like typically 6 to 8 sentences, and they're also translated accordingly. We have translations from 9 different systems, including the most recent large language models, GPT-4o, Qwen, and a few more. And also we have these commercial models, DeepL and Google Translate. And we don't have a multi-agent system. We just have a simple prompt. Please translate the following literary text from German to English, and here's the text. So we have 3 languages, English, German, and Chinese. Here's an example of the English-German pair. We looked at 4 different books, Frankenstein, Jane Eyre, Wuthering Heights, and Burning Wood. So 3 of them are from the 19th century, and the last one is more recent. From those books, we take out paragraphs. So we don't translate everything. Let's say from the first book, we take out 10 paragraphs, and then we have human translations, and we have up to 3 different human translations from different time periods. So this is part of how our data set looks like. And then we go to the evaluation. And we compare 4 popular human evaluation schemes. So that's how is the evaluation conducted. First one is MQN guided error annotation. That's very popular in the standard machine translation community. MQM is basically you look at translations and you label in the translations phrases which you think are erroneous. And I'll show you an example on the next slide. Then, as a variation of that, we also have the free error annotation that's doing the same stuff, but less rigidly with fewer guidelines. We have a Likert score rating where you just say on a scale from 0 to 6, how good is this translation? And we have best-worst scaling, where people are getting 4 translations, and they tell us which one of those is the best translation and which one is the worst translation. All these evaluation schemes have been popular in the NLP community in the last years. And we compare evaluation from students versus professionals, so non-experts versus experts, and also versus metrics. And I'll show you all the results. About who is evaluating, we have students with linguistics and translation studies background. Importantly, they are all native speakers of the target language. That's actually a very important aspect. So from own experience also, it doesn't suffice to just be bilingually fluent. So for example, I myself found that I am not able to judge the quality of a generated English poem, even though I judge myself to be fluent in English, but it's just too hard for me to judge whether that's a good poem or that's a bad poem. And I could also not differentiate it between LLM generated poems in English versus human poems in English. But I could differentiate very well between LLM-generated poems in German and human German poems. And as a second cohort, we have experienced professional literary translators with publication records where we know these are good people. Here's an example. So the source text is nun, den Kasten konnte Gregor im Notfall noch entbehren, aber schon der Schreibtisch musste bleiben. So this is Franz Kafka, for those who have noticed. And so now down there we have the English translation. And in this first evaluation scheme, we do this MQM evaluation. And what evaluators do is basically they go through the translation and they mark parts of the translation as erroneous. And they can also label the category of error. So they can say here, this red part here is adequacy or accuracy error. Maybe down here we have a stylistic error. They even do more annotations. So they also annotate, is this a severe error or is it just a minor error? And out of all those annotations that they do at the end, automatically is being calculated by a formula, one number. So for example, if you would say there are 3 major errors, then each major error gives a penalty of 5, then you're gonna have a penalty of 15, right? So there's some formulaic process to derive a number out of those annotations. Now the free error annotation is actually doing the same stuff, but it's doing less demanding. So we don't say what are the error categories, and we also don't tell people to make a distinction between minor and major error. We did this for our professional translators because they were already quite costly, and we thought, okay, we don't want to further burden them by reading all those translation guidelines, which also takes a lot of hours to understand what's going on. So they were doing this free error annotation. Then the SQM just gives a rating from 0 to 6. And the best worst scaling just has 4 translations at the same time and tells, so now please tell me which one is the best translation, which one is the worst translation. Now the finding number 1, the overall, if we look at aggregate things, if we aggregate over different dimensions, then we find that at least in our experimental setup, the humans are number 1. So here you see the example, human translation. Here's at the top, ranks both according to students and professional translators. They think humans are give the best translations. And second is then GPT-4o. Third and fourth are the commercial systems, Google Translate and DeepL. Then come the smaller large language models such as Qwen. So we also give the model size in billions. There's, of course, a correlation in terms of model size and quality. And at the bottom are the older models before 2020. So these are older models. They are consistently ranked as the worst. So this is the overall message or on an aggregate level. Interesting is also if we look at this SQM from both professionals and students, so there's a bit of a distinction. For example, students believe that GPT-4o is closer to humans than experts believe. So experts think there's a bigger difference. Okay, so this is the overall result. The next thing that we looked at is something that we called adequacy. You can also think of this just as a statistic A, if you don't want to have a positive connotation of the word adequacy. We looked at this statistic A, and this calculates the percentages of cases where the published human translations are judged better than the machine translations. So imagine you have thousands of instances, and this statistics A calculates how often are humans preferred over the MT output. Now for the MT output, we just use the top 4 systems, GPT-4o, Google Translate, DeepL, and Qwen. These were the top 4 systems, and we then calculated for each evaluation paradigm that we had, what does the statistic A say? And here's the result on the left-hand side. So with the source on the left-hand side, you see source text and the translation. Then we have the 3 or 4, depending on how you count. Annotation scheme, we have error annotation, SQM, and BWS. And on the right-hand side, we have the results. And there are 2 axes. The one is scheme complexity. So this error annotation is more complex, more challenging than SQM, which in turn is more complex than just saying which is best, which is worst. And you see that the results vary on this axis. For example, what do we see? We see that for this most difficult annotation scheme, the error annotation, we have the case that is a statistic, so the percentage of cases where humans are ranked better than the NT system is 60% for the professional evaluators and 40% for the student evaluators. So here, if we do this error annotation, then LLMs would seem closer to humans than, for example, if you use the other two annotation paradigms. So if you use an annotation scheme with lower complexity, such as SQM or BWS, then it seems that clearly human translations dominate over LLM-based translations. We also see variations on this other axis, so we consistently find that expert evaluators have a higher tendency to say that human translations are better than LLM-based translation. So we see that results vary depending on how you do this evaluation process and who does this evaluation process. And there's an important aspect to say about this error annotation. So if we use this error annotation, which is the most common thing that people do in traditional machine translation, that's the current state of the art, what people are doing. But perhaps for literary translation, it's not adequate for the following reason, that as we have shown before, human translators are creative sometimes, and they make deliberate omissions, additions, and changes to words. And of course, if you naively classify this as an error, then it seems that human translations are also not so good, right? If you classify this as a creative process, then it's different. All right, takeaways from human evaluation. Evaluator expertise is important. Who evaluates? Choice of annotation scheme or evaluation scheme is important. How you annotate. So these are the two main important takeaways. Now we come about the metrics. We see here now, again, this is the same adequacy statistics. Are humans better than the top systems? Again, to remind you, we had the student and professional translators, and they had, depending on the scheme, values in this A statistic, in this adequacy statistic, between 40 and 90%. Now let's look at what happens when we do the same with an automatic metric called Gemba. It's an LLM-based metric that could replace humans. Now, which value does it have? So we have two variants. So we have the original Gemba, and we have a variant where we tell the metric, actually, here you're in a literary context, and things are a bit different when we deal with literature. So in both cases, the numbers are super low, right? So they are like 5 to 10%. So the metrics have clear preferences to LLM-based output. All right, so let's look at the time. I still... 10 minutes? Okay, good. So that concludes the second thing. Now let's look at the final thing that we have. So now ongoing work, we think about the quest for a good automatic metric, and we call this metric LitTrans Pro QA. And the key idea is we want to get a better automatic metric. You have seen that these metrics are awful, like 5 to 10%. So now our question was, how can we get a better metric? And we want to close the gap to human evaluators. Why do we want to do this? For obvious reasons, because this evaluation is very costly, right? So that costs us a lot of money and resources, and so we would like to have an automatic metric. So we explored two approaches, and initially we were agnostic about which one would work better. We had no idea, so we just said, okay, let's try two approaches. First one is there's a metric called XComet, and that actually XComet was on the same level like Gemba. I didn't show these results now. XComet is one of the state-of-the-art metrics in the machine translation community. It's developed by the group of André Martins in Portugal, and it's a very popular metric. So if you meet this, reviewers typically say, where's XComet? So we said, okay, let's use this metric, and that's usually not, so that's a trained metric, but it's not trained on literature. So we said, okay, let's train that on literature and let's see if it gets better. And the other approach that we had in mind Actually, that was entirely the idea of my student. It was to make a prompting-based metric. So like we make a metric that's based on a large language model that's use a prompt where you say, you are an evaluator. Now here are some two texts, the source text and translation, please evaluate. And we want to put the humans in the loop into this metric. So how do we do that? We leverage question answering and professional translators. And I'm going to show you how we did that. So first, I show you how we fine-tune the XComet. So first, what is XComet? In general, XComet takes 3 or 2, depending on the setup, 2 inputs, a source, a translation, maybe also a human reference. And then XComet is an encoder, a large encoder, a language model, and then that's trained on human machine translations. And then given its input, it gives a sentence level score, a number between, for example, 0 and 100 that says how good is the translation. And besides that, it also gives explainability. It also highlights phrases in the input text where it says this was, well, not in the input text, in the translation that says, okay, here's some error. So this is XComet on a very high level. Now our idea was we expose XComet to literary domain data. So basically we have a lot of data from literature. We have source text, we have human professional translations. We also can input arbitrary empty output from different large language models. And we tell XComet in its training process, you should actually prefer the human translation over the empty output. And that intuitively would make it better on this adequacy statistic that I showed before. And we do this like technically with a triplet loss. You have the source text, the human translation, and the MT. Maybe originally the source text was close to the human translation in the representation space of XComet, and the human translation was maybe far away. And after we do the training, then hopefully the human translation in the representation space is close to the source text. So that's what we did with XComet. And our own metric, the prompting-based metric, is as follows. So what we did first, or what my student did first, we looked at different books about literature translation, and from those books we extracted questions. So these books were basically how to be a good literary translator. So these can be books for humans, of course, right? Like training books for humans. And we extracted questions from those books. And then we had a bunch of professional translators, and these professional translators were weighting the question. So they were saying, this is a really important question, but this other one is not very important. So they were giving a weighting. And then we took those, like we took the top questions, like let's say the 20 most important questions according to the professional translators, and we put those into a prompt. And in the prompt, we also put the source text and the translation. And then basically we told the model, the large language model, where here's a source text, here's a translation, and here are the questions that you should look at to evaluate now the translation. So here's an example. It's a bit small, so maybe I'll read that out for you. So a question could be, is the source text, or does the translation have consistent terminology? So that could be one of the questions. Or another question could be, does the translation contain the author's descriptive imagery? Okay, so these are different questions which then the large language model answers. So it can give answers, yes, no, or maybe. And each yes answer is weighted is given a score of 1. Each no answer has a score of 0. Each maybe answer has a score of 0.5. And then the metric score, the metric gives out a number, that would be just adding up all those yes and maybe answers. So you just add them up and maybe divide by the number of questions, and then you get out one score. And you can also additionally take the weights into account. So maybe if one important question was answered with yes, then that has a higher weight than if an unimportant question was also answered with yes. So this is our metric. So basically, we put humans in the loop into this, into a prompting-based metric. Now, we evaluate the metric from 2 perspectives, consistency and adequacy. The first, consistency, is Each metric now rates a lot of translations. Let's say 1,000 translations are being rated, and the metric, each one every time gives a score, like lit trans pro A gives the score 3 point something. Humans also give scores to that, and then we correlate those scores. That's consistency, and the other one is this adequacy statistic, which I talked before. So in how many of the cases is the published human reference ranked better than the MT output? All right, let's look at the results. So it's also, again, a bit small, I apologize. Here is one data set, but we have 3 data sets and the results are consistent everywhere. First, we look at human translators, and we use here the student, the non-expert translators. And remember, of course, they're going to have a consistency of 1. So if you correlate them to themselves, it's going to be 1. So we omit this number. For this adequacy, they had about this 40-something%, right? In 40% of cases, they said human translations are better. Now let's look at the state of the art. So before we had Gemba, I showed Gemba was between 5 and 9%. Now here's like 6% adequacy. We have other metrics, Comet and XComet. These are variants of this XComet metric. They are at most at 26% adequacy. We also have Prometheus, another like strong model from 2025. This has 16% adequacy. In terms of the correlations, Kendall's tau here, they are between 40% and almost 60%, where Prometheus is the best. So these are the baselines that we consider. Then we look at fine-tuning of XComet. So what's happening with XComet when we fine-tune it? Maybe let's first look at the consistency of XComet. So we have here different experimental treatments and how much data do we fine-tune XComet, on what kind of data do we fine-tune XComet. On average, like this fine-tuning improves the consistency not. So it's basically the original XComet XL has 38% correlation with humans in terms of consistency, and the fine-tuned also has 38. So that actually does nothing on average. If we average over all these treatments, in terms of adequacy, it indeed helps. So the original XComet has 17%, XComet XL has 17%. Now, on average, over all those cases, we gain 1 percentage point. It goes to 18%. But for particular settings, for example, if we now train on French-English data, it would go up to 29%, from 17 to 29, which is a 12% increase. So training on those human translations does improve the model for sure. So it helps a bit, at least in this adequacy statistic. In the consistency, not so much. Now let's look at our models. And again, we also have different ways of doing things, different order of the problems, etc. Not going into those details. What we see in terms of the adequacy, so we look at the best state of the art. The best state of the art here was 57%. So this was this Prometheus, this had 57%. Now, on average, across all our treatments, we get 59%. So we have, like, in terms of consistency, a 2% improvement. Now, in terms of adequacy, these are the really impressive results. Again, the best state of the art was 26.7. So this was this XComet XL, had 26. You can even take, if you want, 29 as the best state of the art. Now, on average, across the treatments, we have 33%, which is a 7% improvement. But with the best model, with the best variant, we get 41% adequacy, which is like a 14% improvement, depending on how you count exactly. And that's now also close to the human non-expert evaluators. So now we have a metric that's actually approaching human non-expert evaluators, which is a cool thing, because like in our past paper, which is just like 3 months old, the metrics were super bad, 5 to 10%. Now we are, in the next paper, we are at 41%. All right, so that concludes my talk, literary translation. And by the way, so that also now decides the question, and we were really agnostic about the answer. What is better, fine-tuning XComet or making human professional translators in the loop? Making human professional translators in the loop is better than fine-tuning XComet. And the overall conclusion is now literary translation evaluation is a delicate task. It matters who evaluates and how. Prompting large language models are not yet at human parity, according to our evaluation, but we also see the gap is closing. We also see that these older systems are clearly a lot worse, and the newer systems, they they are already better. We also find that creativity is what distinguishes humans from LLM translations. In the question of whether multi-agent debate is helpful, we believe this is an open question because perhaps, as I pointed out, the evaluation might be flawed of this paper. And finally, we developed a new metric with good quality, approaching human non-expert evaluation. And yeah, as a final thing, so we can always discuss about limitations of every research. I want to point out one limitation that somebody pointed out to us at a talk, and we could have thought about this ourselves. Could of course also be in this human evaluation, and certainly plays partly a point that professional translators have biases, right? Like LLMs have biases for LLM output, and professional translators also have, and humans also have biases for human output. And especially professional translators might have biases because they don't like AI. And they might be able to identify what is an AI translation. And just because it's an AI translation, they might be tempted to say that's bad. And actually, we saw evidence of that to a certain degree. As my student reported, there was one human translator that thought that all translations were LLM translations. So the translator didn't know that there were also human translations there. And that translator said, all those translations are bullshit. So, so we see there's some evidence for these biases. Thank you very much. That's my talk. If you have any questions.